All right. Hello, everybody. Welcome to a virtual planetarium with Pacific Science Center. Welcome back to those of you who attended some of our other ones. For those of you who this might be your first time, this is a live show. We're going to be talking about space and about planets. If you have any questions or anything you want to say, go ahead and type those into the chat box right next to the video, and we will try to answer as many of your questions as we can. My name is Marissa. I'm a planetarian at Pacific Science Center. And joining me today is Bill, another planetarian. Bill, do you want to talk about what we're going to be learning about today?
Yeah, sure. Hello, everybody. So today we're going to be talking about maybe my favorite subject to talk about, and that's astrobiology of the solar system. Um, we're going to stay in the solar system today because there's just too much going on beyond that. So we won't talk about exoplanets and whether or not there might be life on the exoplanets, but we will look around our neighborhood. We'll save the exoplanets for some other show. Okay, so to get started on this, let's take a look at the one planet we know has life on it. And there we go. And I hope everyone probably realizes that's home sweet home, planet Earth. And it's got some really interesting things that you can see there. I hope everyone realizes that the blue stuff is water. But you know what? So is the white stuff. The white stuff is clouds and ice. And all of that is water. But Earth is really special because it's covered with so much liquid water. The other thing, of course, to notice is the green and brown areas. Those are the landforms, the continents that we live on. But this is the one place we know where life does exist. And astrobiologists who are looking for life in other parts of the universe need to use the Earth as a reference point. There could be types of life that are completely different from life on Earth, maybe conscious gases or who knows what. But we really would not know what to look for, what to recognize if we're that open to any possibility. So to find life that we would understand, we need to look for life like we understand here on Earth. Um, Now, what is really special about the Earth? And I sort of emphasized all that water there. That's maybe the most important thing that astrobiologists are looking for, are planets that are capable of sustaining liquid water. Water is a great solvent, and it helps transport things around, dissolves things. It's really essential to life on Earth. There are two other things that astrobiologists want to look for when we're looking for life elsewhere. One is a source of energy. Clearly, we're all familiar with the sun as our main source of energy here on Earth. Everybody probably knows about plants performing photosynthesis and turning that solar energy into energy that living organisms can use. Um, but there are other sources of energy even here on the Earth. So there are organisms that live deep underground or at the bottom of the ocean where there's no light. And they can survive by using chemical energy, by breaking the bonds of compounds like hydrogen sulfide. That can also be a source of energy. Um, the third thing that we want to look for when we're looking at other worlds is the possibility of complex chemistry. We've all heard that we're carbon-based life here on Earth, and it's because carbon is sort of miraculous. It can combine with other elements in so many different ways that it creates a wide range of molecules. Everything from sugar to DNA is built on carbon and other elements, but carbon being the central one of this very complex chemistry that makes life possible. Okay, so let's take a look at our whole solar system and figure out where we're going to want to look for life. Now, as we're zooming out here, now you're seeing the orbits of the different planets. We're backing away so we can see the whole solar system, or most of it. And just a quick review, the planets that were closest to the sun are the rocky terrestrial planets. That's Mercury, Venus, Earth, and Mars. And then as we move outward, we run into the giants, Jupiter and Saturn, the gas giants, and further out, Uranus and Neptune, the ice giants. Those big giant planets are mostly gas, sometimes frozen, sometimes not, sometimes compressed very much, but very different from rocky terrestrial planets like the Earth. Now, we remember that that major thing that the Earth has going for it is the presence of liquid water. So astrobiologists have identified a zone that they call the habitable zone, where a planet would be the right distance from its star, like the Earth is from our sun, where it could sustain liquid water. Now, if we're going to look at Mercury, that's probably not in the habitable zone. That would be much too close to the sun, much too much solar radiation for liquid water to exist. But Venus and Mars, as well as Earth, may very well be within the habitable zone of our solar system. We do think both Venus and Mars once had liquid water on their surfaces. So we're going to start out by taking a look at Venus. If we could, Marissa, if you could take us to Venus, we'll get a good look.
Here we go.
Thanks. There's Venus. Now, do you think we're seeing the surface of Venus?
Looks kind of cloudy to me.
Yeah, it's just a thick layer of clouds that never open up to show us the surface of Venus. The only way we can see the surface is by using radar mapping or by putting a lander on the surface. But we only see these clouds all the time. Now, there's some interesting things about Venus. One is that its day, its year is about 224 Earth days, but its day is about 243 Earth days. So a day on Venus is longer than a year. Wow. And Venus also rotates backwards. So the sun rises in the west and sets in the east. Very unusual. But let me, Marissa, I have an image I'd like to show everyone of the surface of Venus.
Great. I'll stop sharing for a moment here. Pass it over to you.
I'll switch on my screen sharing and show what I've got here. Let's see. Make sure I'm on the right screen. Is that showing up like it should?
Looks good to me.
So those two pictures are two of only a handful of pictures that we've ever gotten of the surface of Venus. These were taken by Venera space probes from the Soviet Union. The Soviets were actually the first space program to get a lander on another planet. One of the early Venera spacecraft, which these are two examples of, landed on Venus in 1970. It was the first time humans had landed anything on another planet. Wow. But only 4 of the Venera landers, Venera 9, 10, 13, and 14, were able to get pictures back. And the reason they couldn't get pictures back to us is that conditions are very extreme. These two, you're seeing two images, one from the Venera 13 on the left and Venera 14 on the right, if I'm not mistaken. And these are slightly modified images. This fellow, Don Mitchell, took some of the Soviet images of the surface and composited them in a way that we get an idea of what it must look like to stand on Venus. Notice there's not much there. And these landers didn't last very long. And the reason for that is twofold, at least. It's extremely hot on Venus. It's hotter than Mercury, even though Venus is further from the sun. And that's because of that thick atmosphere. We know that Venus is very volcanically active, and volcanoes tend to erupt. One of the things they erupt is carbon dioxide. So Venus has a thick atmosphere that's mostly carbon dioxide. It's actually 90 times denser than the Earth's atmosphere. If you were standing where these probes are, you would feel a pressure about like you would feel if you were 3,000 feet beneath the surface of the oceans on the Earth. It's crushing pressure. But not
Whoa.
only that, you notice it's pretty barren ground. It looks pretty dry too. And that's because it's almost 900 degrees there. It's hot enough to melt lead on the surface of Venus.
Wow, no
And
thank you.
that heat is probably largely to do with that thick carbon dioxide atmosphere. Let all the sun's energy, the carbon dioxide lets the sun's energy in, but it doesn't let it re-radiate back out to space. So it's like a blanket that keeps a planet warm and warms it up. So the surface of Venus doesn't look all that promising as a place to look for life. But we have seen indications from the radar mapping that there are landforms that would only exist if there had been an ocean there at one time. So there is the chance that life may have evolved there. And there are some astrobiologists who are becoming very interested in those thick clouds we saw. So I'm going to stop sharing so we can go back to looking at the clouds from space.
Yeah.
And we'll think for a minute, if you were to rise up through Earth's atmosphere, as you get higher and higher in elevation, the temperature starts to get colder and colder. Some of Earth's highest clouds are made of ice particles. Well, somewhere in that Venusian atmosphere, if you rise up above the surface, there's going to be a region where the temperature would be right for there to be water droplets in those clouds. Now, the clouds have a lot of sulfur dioxide and hydrogen sulfide in there, so they're very acidic. But here are two things that we should think about. One is that Earth organisms, some extremophiles, will live in places on Earth that are very acidic. So being acidic doesn't necessarily rule out life. And we also know that there are bacteria that live in Earth's clouds. So there are astrobiologists who would really like to send something like a blimp to Venus, not a lander, but a blimp that would float around in those clouds and sample the particles there, examine the chemistry, and look to see if maybe life is persisting in the clouds of Venus. That's a long ways down the road, but it's an interesting question. Okay, now let's skip over Earth and fly out to the fourth rocky terrestrial planet, and that would be our red planet Mars.
Bye, Venus.
Mars, of course, is getting a lot of attention these days. And there's a lot of speculation about the possibility of life on Mars. There's some drawbacks, though. So Mars has some things working against the chance of life. One of which is has a very, very thin atmosphere, kind of the opposite of Venus. It is carbon dioxide atmosphere in Mars, but it's less than 1% the density of Earth's atmosphere. So it's actually so thin that if there was liquid water on the surface of Mars today, it would just boil away. However, we think there's some good indications that once upon a time Mars had water on it. If we can move in a little closer, thank you, Marissa. You can see some shapes in the landscape there that clearly look like they've been formed by water flowing across the surface.
Am I pointing to the right spot, Bill?
Yeah, that's a good spot there. There's also a sort of darker patch up to above also shows some of that, but that whole region seems to show signs of water flowing. And there's good sense that there once was an atmosphere that was dense enough to keep water on the surface. What we think has happened is that Mars has cooled off. And what that means is the once upon a time, the core of Mars was molten, just like the Earth's is. You can see those volcanoes, that one very large dot and the three below it, those are all volcanoes. That's Olympus Mons, the biggest volcano in the whole solar system. But it's completely dormant now. We think the core of Mars has cooled off. And one of the consequences of having a cold core is you lose the magnetosphere, the magnetic field around a planet. Earth has a molten core, which creates a nice magnetosphere for us. And the magnetosphere helps protect us from a lot of solar radiation. Now, if Mars is cooled off, it lost that magnetosphere, and the pressure, actually the actual physical pressure of the radiation from the sun probably pushed away much of the atmosphere of Mars, leaving it so we probably can't have liquid water on its surface now. But there is water on Mars. If we fly up to the North Pole, thanks, there you see an ice cap, just like we have on Earth. Mars has both North and South polar ice cap. Probably most of that ice is carbon dioxide ice, but there is some water ice as part of that. And a recent mission, I believe by one of the European Space Agency's orbiters, used ground penetrating radar and found good signs that there may be large lakes of water beneath the surface of Mars, somewhere near the polar caps. So NASA is actually starting to release maps that show how deep they think you would have to dig before you reached water. So there's a fair confidence that there is water there.
Hey, Bill,
Yeah.
I heard that that water might be really super salty. Did you hear that too? Do you think life could live in water that would be that salty?
Yeah, that's certainly possible. Yeah, I have heard that. It would be a lot of dissolved minerals, which is what makes this water salty. And there are extremophile organisms here on Earth that live in extremely saline, salty conditions. So that's within the possibilities of life as we know it here on Earth. So
Neat.
that's a good chance. Interesting thing about the question of life on Mars is our first landers, the Viking landers that landed on Mars, each had a little experiment where they would dig up a sample of soil and analyze the gases that emerged from that soil. And the presumption was that certain gas release would be positive sign of the presence of life. And those experiments did come back positive. It looked like right from the very beginning, we had detected life on Mars. But we have thought of this through a bit more, and scientists have realized that there are other explanations to give that same positive result. So
Oh
those
man.
experiments, yeah, they're inconclusive. I think the scientists who originated that experiment still stand behind their results, but they're in the minority at this point, and it'll take a while to find out. An interesting thing about life, the possibility of life on Mars, is that soon Earth life will probably be on Mars. And that raises some interesting questions about how we're going to deal with trying not to contaminate these new worlds that we come to visit. We might overwhelm Martian life with Earth life before we get a chance to actually detect that Martian life. Interesting problem.
Yeah, all our earth germs.
Yeah. Okay, now we're going to leave the habitable zone. We're going to leave the Goldilocks zone. Why would we do that if we're looking for a place where we might find liquid water? Well, Marissa, if you'll fly us to the space around Saturn and take us to Titan, we're going to
On our
start to
way.
see some interesting alternatives here. Now, Titan is Saturn's largest moon. It's a big moon. It's almost as big as Mars is. It's bigger than Mercury. And it does have an atmosphere that's 60% denser than Earth's. It's the only moon in the solar system that has a significant atmosphere. And here we go. There you see Titan. And notice that sort of brown orange color there. That's an interesting thing going on in the atmosphere of Titan. It's mostly composed of nitrogen and complex hydrocarbons, things like methane and ethane. And when you mix gaseous methane and nitrogen and expose those to sunlight, you get smog. That's the definition of smog. And that doesn't sound real appealing for a living organism, but it's important to keep in mind that 3.5 billion years ago, when life was just getting started on Earth, Earth had an atmosphere that was a lot like Titan's atmosphere. There was almost no oxygen in Earth's atmosphere. It was a lot of hydrocarbons and nitrogen. So this is what Earth looked like when life was getting started. Now, I'm going to, if I could take over the screen again, I need
Yeah.
to show an image of the surface of Titan. Let's see if I can do this. And here we go. All right. There is a picture taken by the Huygens lander, in, I think it was 2005 or so, of the surface of Titan. This is part of the Cassini mission. Cassini was an orbiter studying Saturn and its moons, and it dropped this little Huygens probe to the surface of Titan. So kind of interesting, huh? Notice all those boulders out there in front of you?
Yeah.
Any idea what those might be made of?
I mean, because you say it like that, it makes me think it's not rock.
Well, it's not rock. Those boulders are water. That's water ice. It is
Whoa.
way too cold for there to be liquid water on the surface of Titan. Now, there is some evidence similar to Mars that there may be large reservoirs of liquid water far beneath the surface of Titan. But there's another interesting thing going on in Titan, and I'm going to show another slide here. So this is a picture of Titan from space. Color is a little odd here, but what I want you to notice are those bright spots near the top of this image. That's the North Pole of Titan. And what you're seeing there is the reflection of sunlight off of a liquid on the surface of Titan. It's the only other world in our entire solar system that has liquid on its surface. But obviously it's not water. It's too cold for water. These are lakes of liquid methane. And just like Earth has a water cycle, Titan has a methane cycle. So those lakes will evaporate. The methane will float up into the atmosphere and condense to form ethane clouds. And then they condense further and precipitate, rain down onto the surface, and eventually drain back into those lakes. I love the name of this lake. This is the first one we've identified. It's called the Kraken Mare, the Kraken
Whoa,
Sea.
that's a good name.
Yeah, I like that name. So there are astrobiologists who say, well, maybe there are situations where we don't have to have liquid water. Maybe something like liquid methane could substitute for water in a kind of alternative chemistry for life. So there's some very strong interest in Titan. In a few years, we're going to be sending another probe to Titan. But this one will be a lander, but it won't be a rover like we send to Mars. It's going to be a drone. It'll fly around Titan, so it'll be able to explore large areas, look at the chemistry there, and see if maybe there might be signs of some form of life. We'll find out before too long. All right, there's another moon of Saturn that I think is really interesting.
I also have a question
Oh,
from
yeah, sure.
someone. Yeah, there's a question about what the orange stuff is that we're seeing there. Is those orange, sort of orange rimmed things clouds?
Yeah, I imagine what we're seeing is some of that reflection coming back through thin clouds, the orange color being that sort of smoggy color of the atmosphere.
Oh, yeah.
But
Like
yeah.
a big city or something, yeah.
Yeah, although I don't think there are any cities there. But
Probably not.
but yeah, that's part of that
Smoggy.
reflection, basically. Okay. All right, so next, let's take a quick trip to another moon of Saturn. This one's called Enceladus. Can you fly us there, Marissa?
For sure. Bill, can you let me share my screen?
I have to relinquish my screen.
Yeah, relinquish control.
Yeah.
Awesome. Here we are looking down at Titan again. And let's go.
Here we go. So staying in the Saturnian system, going from this very large moon to a very small moon. Enceladus has a diameter of about 330 miles, which means it's about as thick as Arizona is wide. It's a very small moon. But hopefully, as we approach here, you'll notice that it's also pretty bright. Yeah, here it comes. There's little Enceladus. And it happens to be the most reflective object in the whole solar system. It's a bright white. And you might also notice that there are not very many craters. There are a few craters there, but not a lot. And Enceladus has no atmosphere to speak of, nothing to burn up meteorites that might be hitting it. So planetary scientists would look at this and say, something is reforming the surface of Enceladus. And as we fly there towards the south pole of Enceladus, you see these look like creases, sometimes called the tiger stripes. And if we'll stop there for a moment, I have another slide I'd like to show.
Yeah.
And this is what a picture, I'll show in a moment, a picture taken by the Cassini probe. Let me, oops, one more button to push. There, that's those tiger stripe region of Enceladus. And the Cassini orbiter caught this angle where the light is just right that you can see there are eruptions happening from those creases. These are what we sometimes call cryovolcanoes. And that means a cold volcano, basically. And the Cassini orbiter was able to fly through those clouds and detect the presence of water. Most of what you see there is water being ejected from Enceladus. It instantly freezes once it hits the vacuum of space, and then it rains back down on Enceladus as snow, filling in craters, making it very bright, giving it that snowball appearance. And also, I think it's kind of interesting, one of Saturn's rings, the E ring of Saturn, is formed from this ice that erupted from Enceladus. So this is really interesting. Something is causing the water to erupt from this ball of ice. There must be liquid water somewhere for this to be happening. And that means there's got to be something warming up that ice. So I'm going to just click to another image. This is our hypothesis for what is happening on Enceladus. So we have this thick layer of ice on the outside, but beneath that ice, there must be some liquid water otherwise there'd be nothing to erupt out. It's sort of like the molten magma in the earth, but Enceladus is water. And to keep that water warm, there has to be a source of heat. And what we think is probably causing that is the push and pull, the tug of Saturn and the other large moons of Saturn on the rocky core of Enceladus. And if you've ever squeezed a rubber ball over and over in your hands, you'll notice they warm up. When you tug and push and pull on something, it creates heat. And now if water is seeping down into that rocky core, it's getting heated up very hot, and then it flows back upwards and it emerges from the core as something like a hydrothermal vent. And then that hot water rises all the way up to the ice level, maybe melts its way through, and eventually erupts and becomes that snowfall. So this idea of there's possibility, well, this near certainty, we're very convinced that there is a large global ocean of water beneath that icy surface. And if this hypothesis is correct, there are hydrothermal vents at the bottom of that ocean. And one of the leading theories for how life began on Earth is that it began around hydrothermal vents at the bottom of Earth's oceans. And that's life that did not get its energy from sunlight, but from breaking down hydrogen sulfide and obtaining the energy from that chemical bond. So Enceladus is in a very, very interesting place to astrobiologists because of the possibility that there might be a similar situation to the hydrothermal vents on Earth. And one thing I think I may have forgotten to mention before is when Cassini sampled those jets going out into space, not only did it find water, but it found some organic compounds. That doesn't mean anything live, but organic means it's a carbon compound, which means we do have the possibility of complex chemistry here. So we've got everything you need: liquid water, an energy source, the heat at the bottom, and complex chemistry. Scientists are extremely interested in getting a better look at Enceladus. It's a hot spot for the possibility of life.
Hey, Bill, I've got another audience question.
Sure.
Do we know what the temperature of that water is?
I don't know if we know. I would imagine the best we can do is make an educated guess. I
Mhm.
don't, it's above freezing. I've seen some articles that suggest maybe it's a slush rather than just liquid.
Mm.
But I think the evidence is starting to weigh in more on it's above the freezing temperature. So, um, and then the water that's coming up from the subsurface vents, the hydrothermal vents, could be very hot. The water that comes out of the hydrothermal vents on Earth is, I think, hotter than boiling point, but it's under such pressure it doesn't boil at
Mm.
those kind of depths. So somewhere in between freezing and boiling.
Great.
All
Thank
right,
you.
sure. Okay. Well, we have just one more stop that I would like to make today, and that's to another moon that is a lot like Enceladus. So I'm going to give up my screen, and I'll
Awesome.
ask Marissa if we could now fly back towards the sun, back to the Jupiter space, and go
Yeah.
visit the moon known as Europa. Now, Europa is a much bigger moon than Enceladus is. Europa is actually about the size of Earth's moon. Europa does have a little bit of an atmosphere, and it's oxygen, interesting, but it's very, very thin, so not really enough to sustain life. Um, but very much like Enceladus, the surface of Europa is water ice. There's Jupiter, and here we come to Europa. So you can kind of see it also doesn't have a lot of craters. Um, just something is reforming that surface, filling in craters. And the evidence is that that's ice and that there may be water seeping up. I do have a close up I'd like to show.
Oh, yeah.
If we, let's see, move back here. I'll just show this close-up image of the surface of Europa. Definitely looks like a bunch of ice that's been smashed together, cracking. Looks like there may be places where water has flowed out onto the surface. So first indication, there may very well be liquid water beneath this crust. And other evidence is now showing, yeah, there's probably an ocean beneath this layer of ice that contains more than twice the water of all of Earth's oceans combined. A huge global ocean. And Europa is definitely getting tugged by the gravity of Jupiter and its other large moons, Ganymede, Callisto, Io, creating, again, a source of heat in the rocky core of Europa. So planetary scientists and astrobiologists think Europa is very much the same kind of situation we see on Enceladus. We haven't got good, strong evidence yet for the kind of eruptions that we see on Enceladus, but the Hubble telescope did get a couple of images where it looks like there may very well be the same kind of cryovolcanoes there. All
Cool.
indicating that beneath that ice is a huge ocean of liquid water, and we may have the chemistry and the energy necessary that would make Europa probably our best candidate for where we might find life on a world other than planet Earth. Now, one interesting thing, there are missions being planned. There's a Europa Clipper being planned, which will actually be an orbiter of Jupiter, but it'll be focusing entirely on Europa. Getting a better images of the ice, getting a better sense of the chemistry, maybe getting some good solid evidence of cryovolcanic eruptions, and giving us a better sense of how we might explore Europa to find life. One real drawback to all of these things, one big challenge, I should say, is that that ice is probably about 15 miles thick. So
Whoa.
sampling the water beneath that surface is not going to be a small problem. How we're going to get through 15 miles of ice to see if there's anything alive in the water down there is going to be a puzzle that maybe some of my viewers here today might be involved in solving. But yeah, Europa is a really interesting place. And that pretty much concludes the tour I wanted to give. I think we still have some time. So Marissa, maybe you could, I'll relinquish control again. If you could fly us back towards home, and we'll see if there are any questions from our viewers.
There we are. Remember, if you have any questions, just type them right into that chat box right to the side. Awesome. And let's start flying home.
I see a question there. How much pressure is in the underground water? That's a good question. It's got to be enough pressure to hold the water together as a liquid. And then just like on the Earth, the deeper you get, the pressure is going to increase. But beyond that, I couldn't tell you a whole lot about how much pressure you would feel at the bottom of the ocean on Europa. It is apparently a very deep ocean, much deeper than Earth's oceans. So the pressure could be considerable at the surface of that rocky core. Yeah, it would have to be quite thick. I think so the question here is, how thick would the layer of water have to be more than double the water in Earth's oceans? The Earth's oceans, I think at their deepest point, get to about 6 or 7 miles, somewhere in that neighborhood. I think the estimates for the depth of Europa's oceans put it more in the neighborhood of 20 miles or more than that. And as far as we can tell, that ocean covers the entire planet. So it's a global ocean beneath that ice. So it's deeper than Earth's oceans and covers an enormous area. That's how scientists have come up with a calculation that there may be at least twice as much water there.
Looks like there's another question on there. What kind of life would you expect to find on another planet or moon?
Oh, that is an excellent question. I sometimes forget to mention this. I'm a big science fiction fan, and I enjoy stories about human-like organisms on other planets. As an astrobiologist, or from the point of view of an astrobiologist, though, we're really looking for things that are more like bacteria or archaea. Archaea is another kingdom of life that's very much like bacteria, but they're just one-celled, microscopic organisms. The chances are that that's really what we will find, something on that order. There was a movie came out not too long ago, the Europa Project, I think it was called. And at the end of that, maybe I shouldn't give a spoiler.
Spoiler alert here. Cover your ears if you want to watch that movie.
If you want to watch the Europa Project, cover your ears, because they find something like an octopus beneath the ice on Europa at the end of that movie. That's not real likely, but who knows?
Awesome. So I think that is about the end of our time. Thank you all so much for joining us. Again, this is a virtual planetarium show with Pacific Science Center. Stay tuned to see what other programming we might have over the summer. I had a lot of fun. Bill, I sound like you had a lot of fun.
Yep, this was great. I really thank everyone for joining me today. I love talking about this. It's always fun to have somebody that'll listen.
For sure. All right, folks, take care, stay healthy, stay safe. We'll see you next time.